Today in Algebra 2C lesson 11.4 we are going to talk about rational roots, and in 11.5 we are going to talk about using the Descartes rule of signs. The objective for today is that you'll be able to find rational and other roots of a polynomial with integral coefficients. Here is the rational roots theorem. If we let f of x be an x to the n plus an minus 1 x to the n minus 1 plus an minus 2 x to the n minus 2 and so on all the way to a1 and x to the first plus a0, which is the constant term, where all the coefficients are integers. Consider a rational number denoted by c over d, where c and d are relatively prime. For c over d to be a root of polynomial x, c must be a factor of a0, which is the constant term, and d must be a factor of an, which is your leading coefficient. Let's see in our example number 1, where p of x equals 3x to the third plus 2x to the second plus 3x plus 2, how this rational roots theorem works. We will also find the roots. So let's go ahead and get started and find the factors of a0, which is our constant term. So if we look at its factors, it will be plus or minus 1 or plus or minus 2. Then we are going to look at the lead coefficient, which is an, and find its factors. Its factors are plus or minus 1 and plus or minus 3. Of course, we know that this 2 here is our constant term, and this 3 here is our leading coefficient. So now we need to rewrite these as fractions. So when I rewrite them as fractions, I could have plus or minus 1 over 1, which is just plus or minus 1. And we could also have plus or minus 2 over 1, which is 2. Then we could have plus or minus 1 over 3, and we could have plus or minus 2 over 3. If you notice, my numerator is always a factor of the constant term, and my denominator is always a factor of the lead coefficient. In some of these polynomials, we may notice that we can factor something out. So if we look at this polynomial and we try to do grouping, we probably will be able to factor it just by grouping. So instead of using the rational zero theorem, I can simply use grouping. So I am going to rewrite the polynomial and say p of x equals 3x to the third plus 2x to the second plus 3x plus 2, and start my grouping process. So if I factor something out, I will have px equals, I can factor out an x squared. So x squared times 3x plus 2. From the second set of parentheses, I can factor out 1, and I have 3x plus 2. So now if I take out the common factor, I have px equals 3x plus 2 is my one factor, and x squared plus 1 is my second factor. So to find the roots now, we have to make each equal to 0. So my first root from 3x plus 2 will be x equals negative 2 thirds. And from the second set of parentheses, x will equal to plus or minus I. So I'm going to write it to the side here, 3x plus 2 equals 0. Subtract 2. So 3x is negative 2, and if I divide by 3, I get x equals negative 2 thirds. 2/3 right here. And for my second one, if I do it to the side here, I will get x squared equals -1 if x squared plus 1 equals 0. And if I take the square root of both sides, x will equal to plus or minus I. Notice that this one is not a real root. This will be two complex roots. The question was asking us to find the rational root. So the rational root would be -2/3. And then the second part is find all the roots. So all the roots would be -2/3 and plus or minus I. Since my polynomial had a degree of 3, I knew that I would need to have 3 roots altogether. So the total number of roots had to be 3.